So we know that the quotient rule could be written in two ways. You could use the low d high minus high d low over low squared. So that's the low going to the d high minus the high going down to the d low on there. So it's actually going to be low is the denominator, so g of x times the derivative of the f of x, which is high, minus the f of x, the regular, minus times g prime, the d low, and then low square. So, and then of course this is the product rule, which is just the numerator of the quotient rule, but with a plus sign, and because this is not a fraction. So that's the product rule and the quotient rule. The other video had the product rule. This one here is going to do the quotient rule. Now I know I have to do the quotient rule on here because it has a numerator and a denominator. So the numerator is going to say our f of x and our denominator is our g of x. So when we use the quotient rule, I know that I'm going to need the derivative of f of x, which is just going to be 1, and then derivative of g of x, which is just going to be 2x. So we're going to do the low d high d low, or it's going to be x squared plus 1, the g of x regular, times the derivative of f of x, which is just 1. It's going to be minus, and then we're going to do um, the x, and then the derivative of that. So it's just going to be 2x over the denominator quantity squared. So the one thing that you need to remember is if this one here is not the derivative, this one has to be the derivative. And if this is the original, this is the derivative. So the order does matter with the minus, and that's why anything to help you would remember which one comes first is important. And that's where the low d high minus high d low is going to come in. All right, so now that I have that, that's the derivative of h of x, but this is the calculus part. Now we have to do the algebra part where we have to combine the numerator, never expand the denominator because we want to see whether we could factor the numerator into canceling with the denominator. So the main thing you have to remember is just work with the numerator. So here I am going to get x squared plus 1 minus 2x squared all over x squared plus 1 squared. And then that is going to be, when you have that, it's going to be negative x squared plus 1 all over x squared plus 1 quantity squared. And so that cannot cancel because these are different signs. That cannot cancel. And so we are good to go. So your derivative of h of x is going to be that. You can't factor anything. You can't reduce it any further. That is your answer. Okay, now this one here is a little bit more difficult, and this one here has a product in the numerator and it has a denominator. Um, so therefore, what do you use? Do you use the product rule or do you use the quotient rule? And the answer is you use both. So in order to get the derivative of the numerator, which is your f of x, you're going to have to use the product rule. So I'm just going to erase that and do the product rule for f of x. So f of x is going to be, we could do the same thing. We could say that we're going to leave this one alone. So therefore we have to take the derivative of the other product, and that's going to be ln of e, I'm sorry, ln of 3 times 3 to the x. So that's this one here, the derivative of this one. And so since we're going to do a plus, and since we left this one alone, now we're going to leave that one alone. So it's 3 to the x. And then we're going to take the derivative of the one we didn't leave alone, which is just going to be 2, 2x on there because that's a derivative of that. And so that is the product rule on there. So, and then we need the quotient rule. So, um, what we want to do next is we want to, we know that the derivative of g of x is going to be 2x. So now we do the product rule on that. And the way that we're going to do that is we're going to do the low-de high, high-de low. So this is the whole thing. So we're going to do the low. So it's going to be x squared times the derivative of the numerator, which is going to be all this. So it's going to be, mm, let me just do that in a different color so that we could see. And so we're going to take the derivative of that. So we're going to leave the low, and then we're going to multiply it times the derivative, which is going to be x squared plus 1 ln of 3 times 3 to the x plus 3 to the x times 2x. And so that is your original, that's the derivative. And then we're going to do minus, and now we're going to leave the numerator by itself, 3 to the x squared plus 1. And we are going to then do the derivative 2x. And then this is all over x squared squared. And so that there is your derivative of h prime of x. But we need to cancel a little bit and work through it. And so we end up with h prime of x is going to be x squared ln of 3 to the 3x x squared, because you're distributing it on here, plus ln of 3 to the x, plus this one here is just going to be 2x times 3 to the x. So that's what we have there, minus, and then if I distribute this, it's going to be 2x cubed, because you're distributing it this way and distributing it that way, right? So it's going to be 2x cubed, 3 to the x, minus 2x times 3 to the x. Okay, and that's all over going to be x to the fourth. And then h is then going to be ln of 3, 3 to the x, x to the fourth, plus ln of 3, because what we're doing is we're distributing it to each part of this. ln of 3, 3 to the x times x squared plus 2x cubed times 3 to the x minus 2x cubed 3 to the x minus 2x cubed 3 to the x. Okay. And then that's all over x to the fourth. And if you notice, this part right here, this one and this one are like terms, so those cancel out. And so your final answer is h prime of x is going to be ln of 3 times 3 to the x, x to the fourth, plus ln of 3, 3 to the x, x squared, minus 2x 3 to the x, all over x to the fourth. Because, and then actually, what you could do is, since they all have an x in common, you could actually factor that out. And so when you look at it, we could actually just take that out from there. So we can make this a 3, this a 1, and this one gone. And so we could factor that out over here. And so we're going to have that this cancels with one of that. And so now your actual answer is going to be ln of 3, 3 to the x to the third, plus ln of 3 to the x minus 2 times 3 to the x, all over x to the third. That is a lot of algebra, and that is your answer.